All right, let's dive right into this explainer. If you just glance at a calendar, July 31st probably just looks like the end of another long summer month. But if you look at it through the lens of math history, it is, hands down, one of the most incredible dates on record, and we're going to look at exactly why.
Because on this one single date, literally stretching across different centuries and totally different countries, four distinct, brilliant minds were either born or left their ultimate legacy. And together, they kind of unknowingly built the mathematical foundation for the modern world we live in today. We're talking everything from the graphics on your screens to how we understand the microscopic world. So let's meet them, one by one.
To kick things off, I want you to think about your favorite modern video game, or hey, even just the GPS navigation on your phone. Have you ever actually wondered how a computer knows how to draw a perfectly smooth, curving road using just a few basic data points? Like, how do our digital screens take raw, blocky data and translate it into these flawless, sweeping graphics?
Well, the answer goes all the way back to our first visionary, Gabriel Cramer, born on July 31st, 1704.
Cramer essentially showed us how to use grids of numbers, what we now call matrices, to solve really complex equations that have multiple unknown variables. It was an absolute game changer. It allowed mathematicians to perfectly fit smooth curves to specific scattered points. Before this, working with these kinds of equations was honestly just incredibly tedious. But because of his brilliant work, which you probably know as Cramer's rule, today's computer engines can rapidly calculate the exact math needed to render all those beautiful 3D digital graphics we interact with every single day.
As the saying goes, by finding the missing pieces of a puzzle, we can draw the curves of the digital world. What Cramer's legacy really drives home for us is that underneath every smooth graphic, every curved edge on your screen, there's a beautiful, precise mathematical equation just working tirelessly in the background.
So, that's 1704. But remember, we're still on July 31st here. Let's jump forward in time, a little over a century, to look at a completely different mystery.
Have you ever sat in a quiet room and just noticed how tiny dust particles seem to dance completely randomly in a beam of sunlight? Have you ever wondered why those tiny specks of dust never just settle down and sit completely still?
The answer to that brings us to our second figure, Christian Wiener, who passed away on July 31, 1896.
Wiener was actually the very first person to identify and mathematically prove that this random dancing, a phenomenon we call Brownian motion, isn't just some trick of the light or a gentle breeze in the room. It happens because invisible molecules in the air are constantly, violently crashing into those dust particles. He proved that it's an internal, microscopic motion that's just a fundamental part of being in a liquid or gaseous state. This was a massive leap in helping us finally understand the invisible atomic world that surrounds us all the time.
To quote the idea, even the most random, chaotic dancing in nature is driven by invisible, measurable forces. The crucial takeaway here is that even when nature looks completely unpredictable and chaotic to our naked eye, there is a physical, mathematical reason behind it, literally just waiting to be calculated and understood.
All right, so we've covered digital curves and invisible molecules. Still on the exact same date, let's jump back slightly on our timeline to another brilliant mind. This time, someone who wanted to completely revolutionize how we actually look at and learn these math concepts.
Tell me this, did you ever wish your high school math textbook looked just a bit more like a colorful comic book? Like, how can we make sense of complicated, ancient geometry without getting completely lost in a sea of confusing letters, symbols, and dense paragraphs?
Well, that brings us to number 3, Oliver Byrne, born July 31st, 1810.
Byrne took traditional, dense texts like Euclid's Elements of Geometry and completely redesigned them from the ground up. He boldly replaced all those confusing text blocks and variables with bright red, blue, and yellow shapes. By translating ancient geometry into a pure visual language using those bold primary colors, he essentially pioneered modern infographic design, way before computers ever even existed. He helped us process complex information visually, which is exactly what our modern UI and educational apps do today.
It perfectly illustrates the point that mathematics is not just something you calculate, it's a visual language you can see in living color. What's truly fascinating about Byrne's work is how it proves math is, at its core, a highly visual art form. It's not just something you calculate alone in a dark room, it's a language you can literally see, understand, and appreciate.
Okay, so one date, so many distinct stories. But let's move to our fourth and final dot on the timeline,
to see how all of this mathematical history builds directly to the incredible technology sitting right in your pocket.
Have you ever wondered how we can send high-quality images over WhatsApp or Instagram almost instantly without absolutely destroying our data plans? How exactly does your phone take a massive, highly detailed megapixel photograph and compress it into a tiny, manageable file in just a split second? The secret behind this everyday magic goes back to our fourth mind, Kosambi, born July 31, 1907.
Kosambi was a true polymath. He developed statistics in function space, which was just this revolutionary method to decompose incredibly complex data and signals down into their most important basic parts. Think of it kind of like summarizing a massive, dense book into a few key bullet points. It's the exact mathematical trick that today's engineers use to discard unnecessary data and compress the digital images on our phones. And what's truly amazing? He applied this deep mathematical understanding to entirely different fields, everything from analyzing genetics to calculating the weights of ancient coins. It's incredible.
As the slide says, the same math used to find patterns in ancient history now powers the images on our digital screens. His genius showed us a universal truth. Whether you're studying the wear and tear on ancient Roman coins or compressing modern digital selfies, it is all about finding the essential, underlying pattern.
So, looking at our completed timeline here, every single person we met in this explainer today, across centuries, across continents, was fundamentally asking the exact same question. What is the pattern hiding inside the chaos? And because they asked that, and because they did the math, our world today is fundamentally different. We have beautiful 3D computer graphics, a deeper understanding of nature's chaotic movements, a brilliant visual way to learn geometry, and the ability to instantly share rapid digital images.
Because these four minds found those hidden patterns, our world was forever changed. So as we wrap up this journey through July 31st, I just have to ask you, what patterns are hiding in the chaos of your own life or your own work just waiting to be discovered? Keep looking. Who knows, maybe you'll be the next brilliant mind we talk about. Thanks so much for exploring with me.